it could potentially be a serial killer. So, there is inevitably going to be a feeling of urgency and uncertainty, similar to when you spot a visitor in your backyard and worry that this visitor may soon knock on your front door. This means that you need to act quickly and decide on a course of action. On December 3, 2025, a geophysicist made an astonishing discovery regarding 3IATLAS, a subject NASA has not publicly addressed. In just 4 months, Earth will pass directly through the debris field it leaves behind. This isn't just another comet. The OSIRIS-REx mission has validated that asteroids hold every fundamental component needed for life. Amino acids, the elements of DNA, water, everything. Notably, 3IATLAS is transporting higher concentrations of these elements from another star system. Recently, it erupted globally, casting material into space that we are now set to traverse. Stick with me, as what I'm about to unveil is transformative and will alter everything we believed about the origins of life. Subscribe, because in 4 months, Earth will fly through the debris field left by 3IATLAS at perihelion, and the repercussions extend beyond mere astronomy. Let's clarify what we know with certainty. 3IATLAS has entered our solar system from deep interstellar space. According to the analysis of the Goster catalog, it hasn't been near a star for a minimum of 10 million years. That's a trajectory of 500 parsecs traced back without stellar encounters. For 10 million years, and likely much longer, perhaps billions, this body drifted through the interstellar medium. Cold and inactive, collecting materials like volatile icy, organic compounds, and dust, the debris that swirls between stars. Slowly adhering to its surface, it has been bombarded continuously by cosmic rays, high-energy particles that not only harm materials but also transform them into complex molecules, fostering chemistry in the darkness. Then, on July 1, 2025, it was detected already inside the solar system and starting to heat up. Something dramatic occurred at 2.5 astronomical units from the Sun, approximately the distance of the asteroid belt. On September 7, its brightness skyrocketed by 2 magnitudes, not gradually, but abruptly. This isn't characteristic of standard comet behavior. Comets typically brighten in a predictable manner as they approach the Sun, with ice sublimating and gas reflecting sunlight, producing a smooth brightness curve. However, 3IATLAS made a sudden jump in brightness that has since remained high all the way to perihelion on October 29. This suggests a state change, indicating a global event rather than a localized eruption. The data implies that at 2.5 astronomical units, 3IATLAS encountered enough solar radiation for liquid water to exist on its surface, not merely as ice or vapor, but as liquid. The surface crust, built up over millions or possibly billions of years of interstellar travel, began to sublimate, not gradually, but in a catastrophic event. The entire surface erupted, engaging in cryovolcanism, which is a type of cold volcanism. Instead of lava, we witnessed jets of water vapor, frozen gases, and organic-rich slush shooting out into space. This wasn't the work of just one active vent. The rapid 16-hour rotation period ensured that solar heating was relatively uniform across the surface, meaning that the entire crust activated simultaneously. Imagery following perihelion from amateur astronomers shows multiple jets extending 50,000 kilometers from the nucleus. That's impressive, indicative of sustained, vigorous activity. Here's the chemical signature. There are elevated levels of carbon dioxide and carbon monoxide, a lower water ratio than what we observe in solar system comets, and a heavy presence of nickel. This isn't regular ice. It's processed chemistry, oxidized, volatiles, and metallic catalysts. When you combine water, iron, nickel, and carbon compounds with solar heating, specific chemical reactions occur. The Fischer-Tropsch synthesis, the same industrial method humans utilize to create hydrocarbons from carbon monoxide and hydrogen, is happening here naturally, propelled by nickel-rich surfaces heated by the Sun. The outcomes: amino acids, nucleotides, and simple sugars, the essential building blocks of life. Now, here's why this is significant right now. In December 2025, new findings from the OSIRIS-REx mission have just been released. They analyzed samples from asteroid Bennu, which is a B-type asteroid within our solar system, more processed and exposed to solar radiation than objects from the outer solar system. They discovered a wealth of materials, including 14 of the 20 essential amino acids, 33 amino acids in total, glucose, ribose, the sugar backbone of RNA, and all 5 nucleotides that comprise DNA and RNA, in addition to liquid water trapped within mineral structures. Bennu, being a B-type, is less organic-rich compared to D-type asteroids and not as pristine as trans-Neptunian objects. 3IATLAS bears a spectroscopic resemblance to CR carbonaceous chondrites, the most primitive, metal-rich, and organic-laden meteorites known to us, which are rarer than those of Bennu's class and less processed, yet more concentrated in the exact materials necessary for prebiotic chemistry. If Bennu, a relatively depleted entity, contains all the building blocks for life, just imagine what 3IATLAS could be carrying. almost certainly higher concentrations and perhaps complex molecules we have yet to encounter due to differing stellar conditions. It has just erupted globally, releasing that material into space. Moreover, there's another fascinating aspect. When iron and nickel metals corrode in the presence of liquid water, they form magnetite Fa3O4, which is the most magnetic, naturally occurring mineral. This isn't mere speculation, it's documented chemistry. Magnetite can be found in carbonaceous chondrites that have experienced aqueous alterations, with 3IATLAS's composition featuring high nickel and iron, and water confirmed along with solar heating triggering reactions. It's likely that magnetite is being produced right now as surface materials interact. The formation of magnetite establishes regional magnetic fields on Earth, and the deposits create measurable magnetic anomalies. On Mars, ancient magnetite spots indicate previous water activity. For 3IATLAS, producing magnetite implies it is developing its own magnetic field, not merely the external, temporary plasma field induced by interactions with the solar wind, but an intrinsic field generated by magnetic minerals found in both the crust and potentially deeper layers as these reactions proceed. Why does this matter? Because magnetic fields are protective shields for organic chemistry. Cosmic rays and high-energy particles can break molecular bonds, damage DNA, and disrupt complex chemical processes. Life on Earth thrives thanks to our magnetic field, which deflects much of the cosmic radiation. Without it, the surface would be sterilized. 3IATLAS is in the process of crafting its magnetic shield, not as strong as Earth's but measurable, potentially in the tens to hundreds of nanotesla, according to observations of similar comets. This level of magnetism could reduce radiation damage to surface organics, thus creating protected zones where chemistry can endure. Now, let's delve into what comes next. On December 19th, 3IATLAS will make its closest approach to Earth, about 1.8 astronomical units away. While not particularly close in absolute terms, it is nearer than it has been since our observations began. The sunward-facing jet, the antitail that shouldn't even exist, is still active and growing, even as the primary tail dims and overall brightness decreases. Material continues to be ejected. Adding to the debris stream, the key dates are in March to April 2026. When Earth's orbit crosses the region where 3IATLAS was during perihelion, this is the area where it was the most active and where it expelled those substantial 50,000 kilometers jets, contributing the most material into space. We're on track to pass through that debris field, not directly in 3IATLAS's path, which would result in a meteor shower, but close enough that some of the ejected material, dispersed by solar radiation pressure and orbital dynamics, could intersect with Earth's atmosphere. What is contained within that material? If the comparison to Bennu holds, and if 3IATLAS is as rich in organics as its composition implies, then we might find amino acids, nucleotides, complex carbon molecules, water, and minerals, the very building blocks of life from another star system, falling into Earth's atmosphere. This leads to a philosophical inquiry regarding science. The idea of panspermia, the hypothesis that the components of life, or potentially life itself, can be passed between planets or even stars via asteroids and interstellar matters. This concept isn't fringe, it stands as a legitimate scientific hypothesis. We know that organic molecules can endure in space and survive atmospheric entry via meteorites. The critical question is, how much material transfer is necessary? How many impacts or flybys does it take to effectively seed a planet with a sufficient amount of prebiotic chemistry to trigger biogenesis? That remains unknown. But 3IATLAS presents a unique opportunity as a case study in interstellar visitor, abundant in organics actively processing to create life's foundational components and propelling that material towards us. If this is indeed how planetary systems exchange chemistry, and if interstellar travelers routinely deliver prebiotic compounds during their trip, life might be far more common than we currently believe, not because it evolves independently everywhere, but because the necessary ingredients get distributed across the galaxy. Star systems engage in sharing chemistry through gravitational scattering events that propel objects into interstellar space. Thus, 3IATLAS could serve as a seed not of life itself, but of the essential materials that life requires. Here's what differentiates 3IATLAS from the general panspermia hypothesis. We are observing this process unfold in real time with instruments capable of measuring its composition, tracking its trajectory, and analyzing its chemistry. Previous interstellar visitors, such as Oumuamua and Borisov, didn't provide us with this level of insight. Oumuamua was inert, while Borisov was small and faint. Contrarily, 3IATLAS is massive, active, and measurable, providing us with spectroscopy, light curves, structural imaging, and chemical signatures at a perfect timing. The recent results from OSIRIS-REx related to Bennu have confirmed that even processed solar system asteroids carry everything necessary for life. Given that 3IATLAS is less processed and more pristine, originating from a different stellar environment, It may represent an upper limit of organic concentration and chemical complexity that we are about to sample from its debris field. Not with a spacecraft, as we lack the time to launch a mission, but passively the Earth's atmosphere will collect particles while meteor monitoring networks will log entries. If those particles contain measurable organic, if we will gain direct evidence of interstellar chemistry delivery. Herein lies the frustration. NASA held a press conference, showcasing images and observations, providing safe and simplified explanations. It's described as just a comet unusual, but natural. No mention of the implications regarding Bennu. No acknowledgement that an organically rich interstellar body has just erupted in our solar system and that we are poised to fringe through its debris field. There's no discussion concerning the Panspermia angle or what it means that this object shares compositional traits with the most primitive life-building block-rich meteorites we know. Instead, we're given just another interesting comet. Meanwhile, independent researchers are piecing together these connections. The evidence for cryovolcanism, the production of magnetite, the comparison with Bennu, the timing of the debris field, all converging on the same conclusion. We are witnessing a rare event, perhaps once in a generation, with profound implications for astrobiology, planetary science, and our understanding of how chemistry traverses the galaxy. Yet the official narrative only delivers appealing visuals. So, let's confront reality. 3IATLAS is an ancient interstellar object, possibly between 3 to 11 billion years old. It hasn't been near a star for at least 10 million years and has built up a crust of volatile ices and organics throughout its journey within the interstellar medium. Upon entering our solar system, it heated up and experienced a planetary-scale cryovolcanic eruption at 2.5 astronomical units, expelling enormous jets filled with water, carbon compounds, and metal-rich particles. Compositionally, it aligns with the most primitive, organic-rich meteorites we know and is even more concentrated than Bennu, which has shown it contains all life's building blocks. It produces magnetite through interactions between water and metals, thereby forming a magnetic field that shields surface chemistry from cosmic radiation. When March and April 2026 arrive, Earth will pass through the area where 3IATLAS expelled the most material, enabling us to sample interstellar organic chemistry directly and passively. Whether that collected material is sufficiently complex to be labeled prebiotic, whether it encompasses molecules that we do not have here on Earth, or whether it interacts in any measurable way with our atmosphere or biosphere remains uncertain. However, the fact that NASA is not emphasizing this potential, nor preparing the public for what we may discover, nor framing 3IATLAS as the astrobiological event of the decade, this highlights the gap. Follow along and stay updated because independent researchers are actively following this story without awaiting official confirmation. The closest approach occurs on December 19th, with the debris field crossings set for March and April. Data is on the way, and regardless of whether 3IATLAS serves as a comet or as a factory for interstellar chemistry, it offers us a glimpse into the dynamic exchange of materials between star systems, whether life's building blocks are unique to Earth or prevalent throughout the galaxy, whether panspermia represents a genuine mechanism or remains a theoretical concept. We are about to obtain real, tangible data. Stay curious, continue watching, and remember that significant discoveries often arise from those willing to question the narratives that are typically presented.